Section 4.5, graphs of sine and cosine functions. Some basic terms that you are going to need to know and know how to identify from the graphs or from the equations of trig functions. First thing is the amplitude. The amplitude tells you how high or how low the graph goes from the center line. Second thing is the period. Period tells you how long it takes for the graph to complete one full cycle. For those of you who have taken or are in physics, when you talk about waves, you talk about crest to crest or trough to trough as being the period. Okay, it's the same thing here when we're talking about sine and cosine waves. Y equals a times the sine of x. The absolute value of a, or the coefficient on the trig function, in this case, the coefficient on sine, tells you the amplitude of the graph directly. If we add a coefficient in front of x, so the angle portion of the trig function, the period is always 2 pi over that lead coefficient. Last thing you will need to identify for today is the increment, also sometimes called the quarter period, because it is found by taking 1/4 of the period. So looking at our basic sine and cosine graphs here. Y equals sine x. You will have to identify the amplitude, the period, and the increment for all the graphs that we're going to do today. Tomorrow then we will add on phase shift and center line shift. Amplitude of this graph. Number right in front of the trig function is 1, so that's the amplitude. Period is 2 pi over the lead coefficient of x, so in this case 2 pi over 1, which is just 2 pi, and the increment is 1/4 of the period, so in this case 1/4 of 2 pi, which is pi over 2. So from here, increment is pi over 2, amplitude is 1. So our graph is going to go up to 1, down to -1. Increment is pi over 2, so we start at 0 and we add the increment 4 times. 0 plus pi over 2 is pi over 2. Add the increment again. Pi over 2 plus pi over 2 is 2 pi over 2, which is pi. Add pi over 2 to that, we get 3 pi over 2. Add pi over 2 to that, we get 4 pi over 2, or 2 pi. Now from here, we're going to look at our unit circle that we talked about with our quadrantal angles. One, 0, 0, 1, -1, 0, and 0, -1. Now from here, start, remember this is the XY coordinate plane down here that I have in black. X-axis has the points marked at 0, pi over 2 pi, 3 pi over 2, and 2 pi. Y-axis is going up and down just like our standard coordinate plane. Start with this first value right here and plug in 0. If we plug in 0 for x, y equals the sine of 0. The sine of 0 radians is 0. Remember, for a quadrantal angle, sine is always the y coordinate. Go to pi over 2. Up here at pi over 2, our sine value is 1. So at pi over 2, we have a point up here at 1. Rotate to pi radians. Sine of pi radians is 0. So we have a point at 0 at pi 0. 3 pi over 2. Sine is -1. So at 3 pi over 2, we're down here at -1. When we get back around to 2 pi, our sine value again is 0. From these critical points now, we can see as we go through quadrant 1, if we draw our unit circle in here, Through quadrants 1 and 2, what do we know about the sine function? Well, from our all students take calculus, we know sine is positive in quadrants 1 and 2. And as I begin drawing in the curve here, we see that between 0 and pi over 2 and pi over 2 and pi, we're above the x-axis for all of those positive sine values. When we get up here and we get into quadrant 3 and go into quadrant 4, we see that sine is negative, which we can see here on our graph. It dips below the x-axis for negative values. So there's our graph of the sine function. From this graph now, there are some common things about the sine function that if you know, it's going to make these graphs much more efficient for you to do. You're not going to have to go to that unit circle every single time. The first thing, all sine graphs start on the center line. So in other words, our starting point for our sine graph was right there on the center line. Second thing is our graph is going to either go up or down from that point, and that's going to depend on whether sine is positive or negative. So if sine is positive, like it was here, the graph goes up. If sine is negative, the graph goes down. You're going to want to remember those rules because it's going to be very easy once we have our increment labeled. Once we know it's a sine function then, if we start on the center line, it's positive, we go up, and you're going to use each of those critical points then, so you're going to know the shapes without having to go to the unit circle each time. Second one, cosine. Amplitude, period, and increment. Amplitude is still 1, period is 2 pi, increment is still 1/4 of 2 pi or pi over 2. Amplitude of 1, critical points 0 plus pi over 2, pi over 2 plus pi over 2, pi plus pi over 2, 3 pi over 2 plus pi over 2. There's our critical values. For this first one, again, we're going to go to the unit circle to get where our points are on our graph. Cosine of 0 degrees. Cosine of 0, remember, is the x-coordinate. So at 0, we are up at 1. Pi over 2, cosine of pi over 2 up here is 0. So pi over 2, 0 is an ordered pair. Pi radians, cosine of pi is -1. 3 pi over 2, the cosine of 3 pi over 2 is 0. And 2 pi, the cosine value is back up at 1. Connect those points with a smooth curve once again. Now make sure at these endpoints, when you draw your arrows, remember the amplitude is only 1. So once you get up to this point over here, amplitude is 1. Do not draw your arrow coming up through here because you know the highest that this graph can go is 0. So make sure at those extreme values you're turning your graph back down before you put the arrow on it. Now we can make some general rules for our cosine graphs just like we had for our sine graphs. All cosine graphs start above or below the center line. How do we know whether it starts above or below? Well, whether it's positive or negative. If cosine is positive, as it was here, the graph starts above the center line. If cosine is negative, the graph starts above the center or below the center line. So remember those general rules. That's going to help you be very efficient in creating these graphs as we start adding other things. First one, graph y equals 2 sine x on the interval from negative pi to 4 pi. Amplitude, period, increment. Amplitude, number right in front of the function is 2. Period, 2 pi over the lead coefficient on x is just 2 pi over 1. Increment, 1/4 of that period, which is pi over 2. Now, this time it tells us we need to graph this on the interval from negative pi to 4 pi, so we're going to need to carry our graph out further than what we did before. Nothing else is going to change as far as the setup. Amplitude now is 2, so instead of going up to 1 and negative 1, it's going to go up to 1 and down to negative 2. Increment is still pi over 2, so I'm still starting at 0 and add the increment. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 6 pi, 7 pi over 2, and 4 pi. Now we also need to go to the left because we need to go out to negative pi. So I'm starting at 0, and now I'm going to subtract the increment, negative pi over 2, and negative pi. This is a sine graph. We know sine graphs begin on the center line. It's positive, so it is going to go up first. So at each of the critical values, mark your points following the shape of your sine curve. To the left, it's coming back down and going back up. Connect all those with a smooth curve. Number 2, graph y equals 1/2 cosine x and y equals 3 cosine x on the interval from negative pi to 2 pi. Well, we can see by looking at these two graphs, the only thing that is different is the amplitude. Amplitude of this first graph is 1/2. Period is 2 pi, and the increment is still pi over 2. For our second graph, the amplitude is 3, period is 2 pi, and the increment is pi over 2. So labeling our critical points here, pi over 2, pi, 3 pi over 2, 2 pi. Going to the left, we need to get out to negative pi. So negative pi over 2 and negative pi when I subtract the increment. First one has an amplitude of 1/2. Second one has an amplitude of 3. It's a cosine graph. It is positive, so graphing the one here in blue first. Amplitude is 1/2, starts above the center line. Fill in your critical points. Connect those with a smooth curve. There's your first graph. Second one, amplitude of 3 still starts above the center line, but now it's up here at 3 and follows the exact same pattern. You can see the only two differences in the only difference in the graph is the amplitude. Both have the same intercepts. Both follow the same pattern. One graph goes up higher and down lower than the other. Now looking at some with a period change. Y equals the sine of x over 2. Amplitude is 1. Remember, amplitude is the number right in front of sine, which is 1. Period is 2 pi over the lead coefficient on x, which is 1/2. Simplify that by multiplying up by the reciprocal. Our period is 4 pi. Increment is always 1/4 of whatever the period is. So in this case, our increment is pi. We just need to graph one full period here. So starting at 0, add the increment. 0 plus pi is pi. Pi plus pi is 2 pi. 2 pi plus pi is 3 pi. 3 pi plus pi is 4 pi. Amplitude of 1. It's a sine graph. Sine graphs, we know, always have to start on the center line. It's a positive sine graph, so it is going to go up. Last one, y equals cosine of 3x. Amplitude, coefficient on cosine is 1. Period, 2 pi over the lead coefficient on x, 2 pi over 3. Increment, 1/4 of the period. You get 2 pi over 12, which simplifies 2 pi over 6. Zero plus pi over 6. Pi over 6. Pi over 6 plus pi over 6 is 2 pi over 6. And simplify. 2 pi over 6 plus pi over 6 is 3 pi over 6. Simplify. 4 pi over 6 and simplify. Amplitude, 1. It's a cosine graph. It is positive. Positive cosine graphs start up above the center line and fill out your pattern. Connect with a smooth curve and you're done.